Come on, Timmy, pull yourself together. You got through university, so you can handle this job. You should be excited, not nervous. You're going to be a chemist in a world-class lab.
Hello, you must be Timmy, the new chemist, right? Welcome to Condor Laboratories Incorporated. Come with me. Here is your lab. For your first assignment, I'm going to need you to balance these equations. It should be really easy. I'll be back soon.
Oh no, I totally forgot how to balance an equation. How am I going to prove to my boss that I'm fit for this job?
Hey, over here. I may be able to help you. My name is Billy and I am a lab rat. I have been here for years learning about all of the crazy things you scientists are able to do.
Wow, that's great. So you know how to balance an equation? Will you teach me? I don't have much time.
Yes, but something must be in it for me. If you find me a piece of cheese, I will help you.
Alright, deal.
I can teach you a little about balancing equations. In order for an equation to be balanced, there must be an equal amount of atoms for each element on both sides of the arrow. First things first, it's important that we refresh your memory on the law of conservation of matter. The law states that matter cannot be created or destroyed. Having an unbalanced equation where the number of atoms are not the same on each side almost implies that matter was lost or created as the reaction occurred, which breaks the rule. Furthermore, another important component of balancing equations are subscripts, which are the little numbers you see on the right side of the elements. Do not change them, as it describes how molecules are put together. The numbers on the left of the molecules are called coefficients. You can change those and even multiply them by subscripts to get new values.
Hey, that makes sense so far. Could you show me an example?
Sure, let's start easy. I'm going to walk you through the steps on how to solve this equation. H2O yields H2 plus O2. The first thing you want to do is calculate how much of each element is on both sides of the arrow, which means yields, by the way. So in this case, on the left side, which is also called the reactant side, there are 2 atoms of hydrogen and 1 atom of oxygen. However, on the right side, or the product side of the equation, we have 2 hydrogen and 2 oxygen atoms. So you'll want to add another oxygen atom to the reactant side. You can do this by adding a coefficient of 2 in front of the H2O. This will increase the amount of hydrogen to 4 atoms because you multiply the subscript 2 by the coefficient 2, and this will increase the amount of oxygen to 2. So now our oxygen atoms are equal. But now we have 2 more hydrogen atoms on the reactant side than the product side, which is breaking the law of conservation of matter. So do you know what to do next, Timmy?
Yes, I think so. You would add a coefficient of 2 in front of the existing H2, and now the equation is balanced.
Nice job. On to the next one.
Before we start, what do I do with those parentheses?
You will multiply the subscript outside the parenthesis by the subscripts on the inside. You'll understand better once we get started. So like last time, I recommend that you write out how many atoms for each element are on both sides of the arrow. On the reactant side of the equation, there are 3 Cas, 2 Ps, 12 O's, because you multiply the subscripts 4 and 2 plus the 4 O's in the next molecule, 2 H's, and 1 S. On the product side, there are 2 Cas, 1 S, 12 O's, 4 H's, and 2 P's, and so it looks like our Cas and O's don't match. We can add a coefficient of 2 to the CaSO4 molecule. This will change the sum of the Cas to 3, 2 S's, and 16 O's. Now we will still have to match up our oxygen, hydrogen, and sulfur. This is an easy fix. Let's add a coefficient of 2 to the H2SO4 molecule. Now we have 4 H's, 2 S's, and 16 oxygens. Now everything is matched up. One last equation for you to try and balance. If you can do this, I think you're ready.
Okay, so the first thing I do, I see how many of each element are on both sides of the arrow. So on the reactant side, there is 1 K, 5 O's, 4 H's, and 1 P. On the product side, there are 3 K's, 1 P, 5 O's, and 2 H's. So it looks like I need to balance the K's and H's, so I could do that by putting coefficient of 3 in front of the KOH molecule. This makes there be 3 K's, 7 O's, and 6 H's on the reactant side. Now the H's and O's aren't equal. I guess that I could fix that by adding a coefficient of 3 to the H2O molecule, resulting in 6 H's and 7 O's on the product side. Now the equation is balanced.
Great job. You did it.
Thank you so much, Billy. I never could have done this without you.
Of course, pal. I'm glad I could help.